Okay, let's begin. Hello everyone, welcome to 7th tutorial for the financial econometrics. This week we have 5 questions and it's just related to the regression model. Let's move on to the first question. The first one is two authors published a study in 1992 of the effect of minimum wages on teenage employment using a US state panel. The paper used the annual observations for the years 1977 to 1989 and included all 50 states plus the District of Columbia. The estimated equation is of the following type. So here is the estimated equation, and we can see we got the variable, and here is just explanation for each variable or each samples, like where the E here is the employment to population ratio of teenagers, and I, right, is the normal minimum wage, and W, right, is average wage in the state. In addition, other explanatory variables such as the prime age, male employment rate, and the teenage population share were included. So we just explain the main variables and the mean, like dependent variable, independent variable, and the others they just give you some examples. And let's see what's the questions. So question A, we can briefly discuss the advantage of using panel data in this situation rather than pure cross sections or time series. So here you just include the panel data and the time series or the cross sections. And when we say it's panel data, it's just not only includes for the time, because just only for the time series you only include time. But for panel data is when we have the time. Meanwhile, we also at the same time we have different sections. So that's called panel data. For example, we just discussed the data from the 2000 to 2010, right? But meanwhile, we also discuss when it's at 2000 is like the data from different province, like, right, and this like 6 or 7 province in 2000, and also the same province in the 2001, 2002, 2003, until 2010. So this is called panel data, and the time series just you see it's all only the data is based on is according to the time, it's ordered by the time. And for question B, estimating the model by OLS but including only time fixed effects results in the following output. So here is also like a regression result. And you can see it's variable and you can see the arrow and you can also see the R square. But here's you're only including the time fixed effects, time fixed, and its effects results. So it also explained, right? So the SNHY, this variable is the proportion of the teenagers in the population, and R is the here, right? This variable is the prime age, male unemployment rate. So the coefficients for time fixed effects are not reported. So here, right, they give you like a to tell you pre-tell you that the this coefficient for the time fixed they're not reported. But the numbers in parentheses are homoscedasticity, only standard error. So here we know it's only standard errors, right? And this has been mentioned before. So combined on the above results are the coefficients statistically significant. Since these are level regressions, how would you calculate elasticity? So elasticity is just like the reaction, the situation and the proportion for the reaction when the x change, how it would influence on y. And we also have question C and question D. And because there's too many questions, we just like to figure out the question N and the question B first, and then let's back to the question C and the question D. Okay. So the question A, I think the pro point is explained quite clearly, and you can just simply to have a look, right? Because the first one you just explain why the panel data is more suitable here for this situation, for this condition. So you can see there are likely to be omitted variables in the above regression. One way to deal with some of this is to introduce state and time effects. So you can see it's included state and time. So state effects will capture the influence of the omitted variables that are state specific and do not vary over time, while time effects capture those of the country-wide variables that are common to all states at a point in time. Furthermore, there are more observations when using panel data, resulting in more variation. So this is first one is introduce state time effects, and the state effects, right? Here specific, not vary over time. And but the time, right here is all in point in time. And then if we use panel data, the is more observation and it's the resulting in more variation. So it's quite suitable and it's more suitable for the time only for time series model. Panel data is like a better than it. And then is for like we know the model, and we know that we discussed the coefficient, and we wonder is that like significant, statistically significant, right? And here is just so to explain. So there is a negative relationship between minimum wage and the employment to population ratio. Increase in the shares of teenagers in the population result in a higher employment to population ratio, and increase in the prime age male. Do you remember URAM? That there's a variable. It's just a prime rate age male unemployment rate lower than the employment to the population ratio. So the 20% of employment to population of teenagers variation is explained by the above regression. The relative minimum wage and the prime age male unemployment rate are significant using at just a 1% significant level, while the proportion of teenagers in the population is not elasticities vary. So it's not like that significant vary with the levels here. One possibility is to report elasticity at sample means. And then let's back to the question C and question D. So also the question C, right? But pay attention when we just discuss for the question B, you know that it's only time fixed, right? We only just assume that the time fixed, but we not discussed, we're not considering about the state. But from now on, from the question C, it's just add state fixed. So here we just influence the equation just like that here. So just compare with the original one, only the time fixed here, and then is the state fixed. And you can see it's also right, it's also there won't change here, and r square is 0.069, but this r square is 0.2, right? And the arrow also changed, right? That's different. And you can see the slope here also changed. It's all just because we use the state fixed. And then we compared the two results. Why would inclusion of the state fixed affect the change of the coefficient in this way, right? Just I show you the differences. They are just, and then the significance of each coefficient decreased, yeah, two increased. How is that possible? Or it's just not yet two, it's just r squared. I believe that. How is that possible? What does this result tell you about testing the hypothesis that all the state fixed effects can be restricted to have the same coefficient? How would you test for such a hypothesis? So for the question D, we need to just set up and to show how you just do the hypothesis test. And since the first one, we just need to explain, right? Explain why the things got change. The parameter of interest here is the coefficient on the relative minimum wage. Well, it was highly significant in the previous regression. It now has changed since and is statistically insignificant. The explanatory power of the equation has increased substantially. The size of the other two coefficients has also decreased, right? Definitely decreased because it's only 0.07, 0.19, right? It's 0.33 and it's 0.35. It's 1.53. It's only 0.54. The size of the other coefficient has also decreased. The results suggest that omitted variables, which are now captured by state fixed effects, were correlated with the regressors and caused the omitted variable bias. Is that familiar? So variables could be caused by several results. And here we just give you that not captured by the state fixed effect were correlated. Is that similar? Like we mentioned the last week is also when we have a bias, it's made just because they have a correlated with the regressors. And for the question D, so the influence of the state effects is large. These are bound to the statistically significant, and the hypothesis to restrict these coefficients to zero is bound to fail, since there are linear hypotheses that are supposed to hold simultaneously, and F-test is appropriate here. So we just gave you like a conclusion that for these conditions, for this condition, so F-test is appropriate. And then let's move on to the question 2. For the question 2, it's just the way you need to considering about regression model, and we explain the coefficient x of coefficient, and we just to find out how to do the tax, and we need to write down the net hypothesis and alternative hypothesis, and just based on the sentences. So here we need to like to just read through the question, all the sentences, and we need to like pull the equation out and to set up our own hypothesis test. We can just have look first. Let's consider the simple population regression model where the treatment is the same for the members of the treatment group, and hence x is a binary variable. Explain why the coefficient on x responds to the difference between two means. Now, how is the test for the statistical significance of the coefficient on X related to the test for differences in means between two populations when their variance are different? Write down the non and alternative hypothesis in each case. So here we just know the equation, know the sentences, and we just show you why we can write down the formula and where we can just do the equation and how we do it, right? So let's just begin. So the answer should produce along the lines of regression when X is a binary variable, right? So where the binary variable now indicates whether or not an individual has received treatment. In terms of the regression model with a single regressor, this is formulated as, right? So this is a basic if regression model for it only include one variable. And here's the arrow term. That this is the intercept coefficient and the one variable. So you can see with a single regressor, so this is the basic equation, and you can write down where the xi is 1 or 10, depending on whether or not the individual receive treatment. So why x just become the 1 or 0? It's because it's been like binary variable. And then in the case of no treatment received, why, right? Because it did not receive, and according to us assumption, so it's the 0, right? So x equals to 0. If x equals 0, the equation only becomes here. So it just when the equation and expectation value is become the beta 0. And alternatively, when treatment was received, right, when x equals to 1, it just become to the beta 0 plus beta 1 plus the arrow. And right, so it becomes to the beta 0 plus beta 1. Hence, beta 1 is the differences between the two means. It's quite easy, right? Because when x equal to 0, the result of beta 1 has become to 0. But when x equal to 1, the result is like a beta 1 is add beta 1, right? Beta 1 is not 0 anymore. It becomes have a significant value. And to test whether or not there is differences, right? There is a difference. The hypothesis tests that beta 1 equals to 0, all beta 1 not equals to 0. Because these two different means and this different result, they're different just beta 1. So when beta 1 equals to 0, that means that they don't have any differences. But if beta is not equals to 1, that means that their difference is 1. It's the beta 1. And because beta 1 not equals 0, so they're not same. And we just want to figure out whether they're same or not, whether there's any differences or not. So the null hypothesis can be tested using the usual T statistic and allowing for the heteroscedasticity robust standard error. It's not the standard arrow. Where is it? It's not like the question 1, because the question 1 I think it's just here. Never mind. I just want to still tell you the difference. It's the homo, right? It's the heter. So they have different. And one is standard arrow, and one is the robust standard arrow, right? So you can see. here's this is the net hypothesis and the alternative hypothesis. And the standard error of the differences in means is calculated under the assumptions that two population variance are unequal. And then let's move on to the question C. So question C is also just like it's similar with the question 2, but we just need to explain in another way. We can just have a look first. So the define of the beta just difference in terms of observable differences in the treatment and the control group before and after the treatment. Explain why this presentation is the equivalent of the calculating the coefficients in regression framework. So we need to calculate the differences, right? And we need to explain. And here, because you can see the change of y's just have a basic equation. And we know that, right? So data differences. So here just to give you what becomes for the equation. You can see the beta 1 just equals to the treatment after minus it before. Actually, it's just a change of the y, right? And also, it's the control after minus before. It's also the change. And this just compare the differences between the change of the treatment and control. And here, it's become this equation. And where the y is the value of the I individuals after the experiment is completed, means the value minus value of the y before it starts. And the x is a randomly assigned binary treatment variable, which takes on the value of 1 if treatment was received and is 0 otherwise. So it's quite clear. I also 1 and 0. But the 1 is treatment, and 0 is not. You did not get treatment. Then for an individual who did not receive treatment, right? So the first one, we know that was the beta 1 difference in difference, right? I will show you. I mean, it's just differences between the change of the treatment and control. And then here, the differences just between the control. You see it's the use the after 1 and minus its original one is before 1. It's because the bar beta 0. And if the individual received the treatment, then it becomes the beta 0 bar plus beta 1 bar. And you can see beta 1 bar is just equals to here. And it's nothing different, just what I told you before. Just use the differences, the change of the treatment and minus the change of the control. Right, you can see the clearly. You can just have 1 minute to have a look. Right, music bits become beta 1, become here. And then you know it's beta 0 and beta 1. And if it's received the treatment, if it's received treatment, it becomes 1, right? And here, so beta 1. And then let's move on to the question 4. For the question 4, actually for the question 4 and the question 5, they also give you can see before and after, and it's a table, and they give you the information. And we just have a look for question 4 first. So like the vertical axis of the figure indicate the average employment fast food restaurants. There are two time periods, T1 and T2. So time periods, right? Here is you got one, first one T equals 1 and the second one T equals 2. Where the time period is measured on the horizontal axis. The following table presents the average employment levels per restaurant for New Jersey, the treatment group, and the Eastern Pennsylvania, the control group. So it's short by PA and NG. Here, New Jersey, right? CCNG, and here is the PA. And you can see the employment before and after the two time, and you can see the numbers here. So enter the 4 points in the figure and label them. So it's the treatment before, treatment after, control before, control after. And connect the point, finally calculate and indicate the value of beta 1. So actually question 4 is related to question 3, and we just use the question 3 to show you that, oh, that's the equation, and you can follow this equation. Right? The same equation. It's just a change. It's the differences with the change of treatment and the change of control. And you can see it's quite simple, right? You just use the after minus before, then minus after minus before. It's quite simple, right? And you can get the answer. And here is just a figure I show you. You can see treatment T1, T2, and you can exactly get number 21.3003 and 20.44. You just get 2 points because when you get 2 points, right, you can get a line. So when I get 2 points, I got a line, right? 2 points a line, 2 points a line, and you can see here is the difference. And then the last questions. Actually, this whole 5 questions just will let you to have the concept and have just a meaning. You can understand. Oh, this is the you can see when we just calculate all this regression model and how it's calculated for the net hypothesis, and it's the figures how we can figure out all of those things. It's not that quite hard, and but it's like essential for you to know. You need to understand what's the meaning, like in the table in the regression model. And then let's move on to the last question. So this just you use this like also an experimental study, right? It's also influence and also figure out the minimum wage on the employment on using the data from the fast food restaurants in 1992. There was an increase in the state minimum wage in one United States. So it's one United States and it's New Jersey, but not in a neighboring location. Esther, Pennsylvania. Pennsylvania. To calculate the, you need to change into the treatment, right? We need to calculate the beta differences. The group and the change in the control group. To do this, the study provides you the following information. It's also the information. So where? So FTE is equals to the full-time equivalent. So equivalent, just you can the numbers and average employment per restaurant. So also before after. And 1, 2, 3. So it's have 3 questions. And then we can see the first question, question A, right? We calculate the change in the treatment group, the change in the control group, and finally the beta 1, the differences in differences. Since minimum wage represent a price floor, did you expect that it will be too positive or negative? And then if you look at the beta 1, is this number primarily due to a change in the treatment group or control group? Is this what you expected? And then the standard error for it is 1.36. Test whether or not the coefficient is statistically significant. And given that there are 410 observations, if you believe that the benefit from small minimum wage increase outweighs the cost in terms of employment loss, would finding that this coefficient was not statistically significant discourage you, right? So basically, just all these three questions that you is based on you already know the equation for how to calculate the beta one, and we just mentioned for the last questions, and you know how to do it. And based on the equation, then we know all understand the positive or negative, and does it influence the much more is based on the treatment group or the control group. Then this one, can you explain, and can it is not statistical significant or not? It's like that. And then you can see change in right is just so similar with the question 4. You just right use it to have differences and just minus, right? Just minus, and you can just get the answer. So you can see the treatment is the 0.59 and the control is negative 2.16. You can see just the differences. You use the treatment to minus is the control group, and it becomes to the 2.75. The standard economic theory suggests a negative, not positive change. Then for the question B, the overall change of the 2.76, right? You can see, I think it's 2.75 here. It's not 76 because we've already calculated. We just calculated 7.5. Because it's quite easy, right? So because it's primarily due to the change in the EPA is 2.16, you can see clearly it's only just influence change is only 0.59, but here it's changed 2.16. Whether it's negative or positive, it doesn't matter. It's negative or positive. It's because it's changed, and the change, the value is 2.16, right? And so it's just more based on the control group. Following the standard economic theory, if employment fell in the Eastern Pennsylvania, and then you expected employment in New Jersey to fall by even more than in the PA. Now, not only did employment in New Jersey not fall by less, but it actually increased. For question C, you can see here the arrow tone right is 1.36. And have you remembered that how to calculate the t statistic? Use the upper one is the coefficient that divided by its arrow. So the t statistic is 2.03, thereby making the coefficient statistically significant at 5% level to set test. Even if the coefficient was not statistically significant, it is not negative. Hence, finding an insignificant coefficient should be discouraging since it suggests that there's no negative employment effect of a small increase in minimum wage. That's pretty much for question C, and that's pretty much for all the 5 questions for this week. And hopefully this is just the last tutorial for all the course, and just hope all you guys could have a really good effects and have good work, and you will have excellent performance in the final exam. Just to give you all the best wishes. Here's pretty much for this week. Thank you all guys for this whole term. Thank you. And if you have any questions, don't be afraid to ask me and email me. And all the materials you will be find just via the Moodle page under the just FE tutorial section.